Hello everyone, let me take a look if I'm live. Okay, I think I am. So, yeah, what we're doing on my stream, I'm usually reading the Rust book. We passed through the 8 chapters already, and I'm kinda going to start 9th chapter today, but yeah, I decided to play around with the NeoVim config. What is bother me with this when I practiced the Rust reading the book, you see this code is not formatted, and I would like to have a hotkey to easily format it like I'm doing it in my TypeScript project. For example, if go to some TypeScript, I can do something like this, then press my kmap, which run prettier, and the buffer is formatted for me, so like this. So I want to have same behavior for the Rust. It has cargo fmt, I guess, kind of do it, but it's not happened immediately, so I like to try do something similar to prettier. So yeah, I think I will start with my NeoVim config, maybe create some Rust directory and formatter Lua. So yeah, we will play around here. I don't know, maybe just let's print something. And this is Rust formatter, like this. And let's go to init Lua. Require yeah, you see this is rot formatter print here, so we are good. Our file correctly included, and we can start coding here. So first of all, there is a format command in the NeoVim, so maybe it's something will work also. Vim lsp buff format. Maybe it will just work for the Rust as well. Let's go to the Rust project, unformatted, run format. Oh, it's working. So and I think I have kmap for this. Kmaps We can check it in Telescope. Yeah, C space CF, leader CF should actually format it for me. So I don't need to do anything. Oh, this is great. I don't know why I haven't tried it before. So I think we are good, and we can back to our book reading then. So let me update the title then of my stream. Updated, and Twitch, is it updated? I don't know. I hope it is. It showed me, but yeah, it should be updated now. So let's quickly back to what we done yesterday on the stream. We finished with the command collection, and there was some exercises. I was thinking if I would like to solve them on the stream, and I quickly checked that there is some information I need to check before solving, like what is vector median, etc. It's not a big deal to solve it, but I need to spend time, and I actually already know the project I want to do in Rust, so I just want to move forward with the book to get enough knowledge to actually start the project. So I will not waste the time on this exercise, but basically, yeah, if you don't know what you're gonna build with Rust and you want some practice, it's definitely worth to do exercises. And maybe we also do Rustlink as well to practice a bit syntax, some error handlings, etc. The play with concepts. Okay, so today this chapter 9, error handling. Let's start with it. So errors are fact of life in software. So Rust has a number of features for handling situations in which something goes wrong. In many cases, Rust requires you to acknowledge the possibility of an error and take some action before your code will compile. This requirement makes your program more robust by ensuring that you'll discover error and handle them appropriately before you deploy your code to production. Okay. Rust group errors into two major categories: recoverable and unrecoverable errors. For recoverable errors, such a file not found error, we most likely just want to report the problem to the user and retry the operation. Uncoverable errors are always symptoms of bugs, like trying to access a location beyond the end of an array, and so we want to immediately stop the program. I see it's the second time, and in the book, like, we have index out of bound and we want to immediately stop the I don't remember ever I wanted my program just stopped or crashed, whatever, because I have some error. I would like to keep it working for the user, even if there is some weird scenario which is not working. I don't think I like to crash it or something. But anyways, let's continue. Most languages don't distinguish between those two kinds of errors and handle both in the same way, using mechanisms such as exceptions. Rust doesn't have exceptions. Instead, it has the type result for recoverable errors and the panic for macro that stop executing when the program encounters an unrecoverable error. This chapter covers calling panic first and then talks about the returning result values. Additionally, we'll explore consideration when deciding whether to try to recover from an error or stop executing. Yeah, good topic. Definitely like to see it. So yeah, we're done with the intro. Let's jump onto something more specific. And this is section 9.1, unrecoverable error with panic. So sometimes bad things happen in your code and there is nothing you can do about it. In these cases, Rust has the panic macro. So yeah, sometimes bad things happen and okay. There are two ways to cause a panic in practice: by taking an action that causes our code to panic, such as accessing an error past the end, or by explicitly calling the panic macro. In both cases, we cause a panic in our program. By default, this panic will print a failure message, unwind, clean up the stack, and queue it. So via environment variables, you can also have Rust display the call stack when a panic occurs to make it easier to trace down the source of the panic. All right, so what the point was, there is two ways to cause a panic in practice: by taking an action that causes, or we can do the macro panic in it. Let's quickly run it actually. It expected something like this. Syntax semicolon. Okay. So run. Thread main panicked at explicit panic at line 8. Run with Rust backtrace1 environment variable to display a backtrace. Actually, let's try. So we do it like this, cargo run, and you see we have backtrace, Rust begin unwind, core panic fmt, panic main, etc. Okay. So there is a note unwinding the stack or aborting in response to a panic. By default, when a panic occurs, the program starts unwinding, which means Rust walks back up to the stack and cleans up the data from each function it encounters. However, this walking back and cleanup is a lot of work. Rust therefore allows you to choose the alternative of immediately aborting, which ends the program without cleaning up. So okay, there is and what happened if we don't clean? What will happen? Memory that program was using will then need to be cleaned up by the operating system. If in your project you need to make the result in binary as small as possible, you can switch from unwinding to aborting upon a panic by adding panic abort to appropriate profile section in your cargo toml file. For example, if you want to abort on panic in release mode, add this. Okay, maybe it's something we should know for ourselves, but don't really care about it for now. I wonder what you need to be cleaned by operating system. What does it mean actually? Does it mean operating system will take care about it for us somehow? Or should we do anything, or what? Or it depends on the operating system? Really unclear. But anyway, let's move on. So yeah, we can add some message in the panic. Do we see it here? Yeah, the thread main panicked at crash and burn. So we can put some messages inside. All right. When you run the program, you'll see something like thread main panicked at crash and burn. Yeah. The call to panic calls the error message containing the last two lines. This one. Do we have last two lines? Not sure. Oh, we have a message in the last two lines. Okay. The first line shows our panic message and the place in our source code where the panic occurred. Yeah, indicate that the second line fifth character of our src main rc file. Sorry. In this case, the line indicates it's part of our code, and if we go to that line, we see the panic macro call. In our cases, the panic macro call might be in code that our code calls, and the file name and file number reported by the error message will be someone else's code where the panic macro is called, not the line of our code that eventually led to the panic call. We can use the backtrace of the function the panic call came from to figure out the part of our code that is causing the problem. We'll discuss backtrace in more details next. So backtrace, yeah, we swiftly tried already. So let's look what we have in this paragraph. Let's look at another example to see what it's like when a panic call comes from a library because of a bug in our code instead of from our code calling the macro directly. Listing A91 has some code that attempts to access an index in a vector beyond the range of valid indexes. Yeah, let me quickly create new project. Cargo new. Let's name it Panic 91. Run nvim. Go to main RC. So let we some vector thanks copilot and try to access the outbound index. So cargo run. Thread main is panicked at index outbound. The length is 3, but the index is 99. And what we can do cargo run with backtrace. But actually I don't think we have much more information since we just in main. Yeah, backtrace is more interesting when you have the panic. You can see the tree of the calls, and it helps you understand what happened in the app. But here it's simple as it is. So yeah, here we attempted to access hundreds element of our vector, which is at index 99 because indexing starts at 0. But the vector has only 3 elements. In this situation, Rust will panic. Using square brackets is supposed to return an element, but if you pass in invalid index, there is no element that Rust could return here that would be correct. Yep. In C, attempting to read beyond the end of data structure is undefined behavior. You might get whatever is at the location in memory that would correspond to that element in the data structure. Even so, the memory doesn't belong to that structure. It's so confusing. Yeah, this is behavior. Like some time ago I just started to look in some basics of C++, and yeah, you can create a variable, don't assign anything to it, and it just will return some random shit from the heap, and it's super confusing. Like, how are you supposed to debug it? Like, it's like in this simple program, if you initialize something and you take it and you see, oh, okay, I don't initialize it, so I don't expect anything. But in the complicated program where in the middle of something the variable isn't have the value you expect it to have, it could be so tricky to find out what is the problem. Like so yeah, debugging can be really hard. So I'm happy and the Rust don't have it, and maybe this is why I'm trying to learn it. So this is called a buffer overread and can lead to security vulnerabilities if an attacker is able to manipulate the index in such a way as to read data they shouldn't be allowed to that is stored after the data structure. Yeah, other side is also security problems. To protect your program from this sort of vulnerability, if you try to read an element at the an index that doesn't exist, Rust will stop execution and refuse to continue. Let's try and see. So yeah, we tried and we saw it. This error points at line 4 of our main RC where we attempt to access index 99. The next node line tells us that we can set the Rax backtrace environment variable to get a backtrace of exactly what happened to cause the error. A backtrace is a list of all functions that have been called to get to this point. Backtrace in Rust work as they do in other language. The key to reading the backtrace is to start from the top and read until you see file you wrote. That's the spot where the problem originated. The lines about that spot are code that your code has called. The lines below are code that call your code. These before and after lines might include core Rust code, standard library code, or crates that you are using. Let's try getting a backtrace by setting Rust backtrace environment variable to any value except 0. Listing 9.2 shows output similar to what you see. Okay. So yeah, basically already tried. So what we have here, Rust begin unwind, and we see there is some library std src panicking. It's actually, I'm thinking, so it starts here, like, or it's finished here. I think we start here with library core src functions. Then in our code main rc get panicked and line 4 this, and then yeah, this is when we try and access the index, I guess, and it leads to the some core panic functionality. Okay, so let's read about it. That's a lot of output. The exact output you see might be different depending on your operating system and Rust version. In order to get backtrace with this information, debug symbols must be enabled. Must be, okay. What does it mean? Debug symbols must be enabled. Debug symbols are enabled by default when you're using cargo boot or cargo run without the release flag, as we have here. But I guess for release we can enable it as well. In output listing 9 to line 6 of backtrace, point to the line in our project that caused the problem, line 4 of main RC. If we don't want our program to panic, we should start our investigation at the location pointed to by the first line mentioned a file we wrote. Yeah, basically it's similar to any language and kind of obvious for me, but if you knew, basically when you see this weird lines of error and maybe don't know what to do, you just need to find actually the the line where you see your code, like files created by you. In our case, it's like you see, this is everything raster, C something. So this is code Rust, but there is also in the root folder src main.rc, which definitely it's our sources. And something wrong on the line 4 column 5. So this is here 4 5. Something happened wrong here. So when you find, like, you have this error and you find the place, you can start thinking, okay, what can be wrong here? And we actually see what is wrong, like this. So where we stopped, listing 9.1, where we deliberately wrote code that would panic. The way to fix the panic is to not request an element beyond the range of the vector indexes. When your code panics in the future, you'll need to figure out what action the code is taking, with what values to call the panic, and what the code should do instead. We'll come back to panic and when we should and should not use panic to handle error condition we in the panic or not to panic. And where it is, it's okay, this is section 3 of this chapter, so we'll back to it later. Yeah, it's interesting topic, specifically for me. So yeah, I'd like to see, because when I'm thinking about it, I don't really want panics in my program at first, but then I remember the case, for example, if you created some, I have open source project and it requires initial configuration, so you need to provide some credentials from your server, and basically I don't want to start if you don't provide configuration. So maybe this is the place I would like to stop, or maybe not stop, maybe show some explicit. Better way is to show information that you did something wrong and explain where to find it in the documentation, but yeah, you can do it with panic maybe. But I think there is something else which we will see in section 9.3. So let's continue. Okay, this is big section. Actually, I already see it. So recoverable errors with result. Most errors aren't seriously enough to require the program to stop entirely. Sometimes when a function fails, it's for a reason that you can easily interpret and respond to. For example, if you try to open a file and the operation failed because the file does not exist, you might want to create the file instead of terminating the process. Okay, so yeah, definitely the case. We don't want to finish working if we just fail to open something. Recall from handling potential failure with result in chapter 2 that result in num is defined as having two variants, okay, and error as follow. Chapter 2 is about the guessing game, so yeah, we just did something without understanding it really, but now we know this is a num result. which can bound to can be okay one with attached value, which is generic and can be different, and same for the error with some attached value. For example, string, we can specify error with some string or code number. Anyways, the T and E are generic types parameters. We'll discuss generic in more detail in chapter 10. We are really close. Yeah, chapter 10 is the, I feel like this is equator, maybe we will start writing our program after chapter 10. I don't know if it's already enough. Maybe after 12. Yeah, the building command line program. This is maybe the point we'd like to start. But yeah, there's many more chapters. So let's move on. What we need to know right now is that T represents the type of the value that will be returned in a success case within the OK variant, and E represent the type of the error that will be returned in a failure case within the error variant. Because result has these generic type parameters, we can use the result type and the functions defined on it in many different situations where the success value and error values we want to return may differ. Okay, someone subscribed. And is there, I wonder, is there comments on the YouTube? I can take a look. No, I think there is no comments. I need to figure out how to forward comments in one chat. I see my Twitch chat, but not the YouTube. Anyways, let's move on. So let's call a function that returns result value, because the function could fail. Listing 9.3, we try to open a file. This is interesting. So yeah, let's do this. Actually, we can skip this example. Use std, I guess io, what, not io, fs file, then let greeting file result file open hello txt. So, and we can see that the variable type is a result, which attach file type to OK value and error to the error. All right. The return type of file open is a result. Yeah. The generic parameter T has been filled in by the implementation of file open with the type of success value std fs file which is a file handler. The type of E used in the error value is stdio error. This return type means the call to file open might succeed and return a file handle that we can read from or write to. The function call also might fail. For example, the file might not exist, or we might not have permission to access the file. File open function need to have a way to tell us whether it succeeded or failed, and at the same time give us either the file handle or error information. This information is exactly that the result in num conveys. Okay. In the case where file open succeeds, the value in the variable greeting file result will be an instance of OK that contains a file handle. In the case where it fails, the value in greeting file result will be an instance of error that contains information about the kind of error that happened. Actually, we already knew that we can use match. Sorry. Yeah, I just wanted to use format, which I learned in the start of the stream, how to use it. So can we do it like this? Okay, yeah, I already forgot how to use it, but Copilot suggests something. File found. But I don't want only file found, but actually want to see what in file handle, if it's possible. And for the error, it uses, okay, there is an error. It's not implement display. Yeah, maybe we don't have way to print at the handle, but let's just run and see what happened. No such file or directory. Yeah, sorry, I just thought maybe next time we add a new vim config kmap to run, because we do this cargo run command so many times and feels like maybe I'm wasting my time. I can automate it and be happy. I already, yeah, definitely have something to implement in my new vim config to be more productive in the Rust with my current needs. But for now, yeah, you definitely don't have this file. What if we create the file next to our manage C? If we do it text txt cargo run again. No such file. What if we do like this? And no such file. And maybe, oh, maybe it's should be placed near the binary. So our panic program is here. What will happen if we run it like this? It's still not there. Maybe last try. Oh, sorry, I'm using the wrong name. Created text.txt. Jesus. So cargo run not found. Okay, but now I think we should. Where should we place it? In the root? Cargo run. File found. Okay. So now we know that open is looking into the root directory. You see there is an example which after we create mutable variable to the file open, we use awk. Not sure what it does, but yeah, let's back to our book. We need to add to the code in listing 9.3 to take different actions depending on the value file open returns. Listing 9.4 shows one way to handle the result using basic to the match expression we discussed in chapter 6. And so okay, in this case we're returning the file, and in case of error we do panic. Okay, so we can replace this with panic, and this one we can return file and file handle like this. Do we need semicolon here? I guess. And then cargo run. Okay. So note that like the option enum, the result enum and each variant have been brought into scope by the prelude. Okay, so we don't need to include it in our main RC with use keyword. It's actually not include, but yeah, it's creating some alias to the path of the option where it's stored in the library, etc. So we don't need to specify result before the OK and error variants in the match arms. Yeah. When the result is OK, the code will return the inner file value out of the OK variant. And We then assign the file handle value to the variable greeting file. After the match, we can use the file handler for reading or writing. Okay. The other arm of the match handle the case where we get an error value from file open. In this example, we choose to call the panic macro. If there is no file named hello.txt in our current directory and we run this code, we'll see the following output from the panic macro. Yeah, let's actually do the case. We can see this panic macro. So panicked add error is code 2 kind not found, message no such file or directory. Okay. Matching on different errors. The code in listing 9.4 will panic no matter why file open failed. However, we want to take different actions for different failure reasons. If file open failed because the file does not exist, we want to create the file and return the handle to the new file. If file open failed for any other reason, for example, because we didn't have permission to open the file, we still want the code to panic in the same way as it did in listing 9.4. For this, we add an inner match expression shown in listing 9.5. So for the error we unwrap from the enum, we can do match again. I think we can go and see the result file. See more about error. Okay, I think it's not as easy as I think. Oh, sorry. I did close by mistake my alacrity. So yeah, let's back to where we were, but yeah, let's increase in size. Yeah, I just got an idea that I maybe need to show my keystrokes on the stream. So let me write this point to prepare for the next stream. Add keystroke. So it might be useful for someone. So where we stop, yeah, we want to, instead of just panic here, we want to check kind of the error. So the error have kind and kind return error kind. And error kind is, I don't know what it is, but we can do match. Let's stick to the book code. So error kind Oh yeah, we need to kind of import it. Use stdio error kind and okay. In the no, not okay. Error kind not found. In this case, it's such not obvious structure. So we have match. In this match we have match. Sorry, I did press something and we jump out from the page. So we have a match. Set this match on the error. We have a match. And if not found, we have match again. And we return new file. This will be similar to result here. So it will be returned to the greeting file. In case of error, we will panic. Okay, so not found. We do match again. And what we do file create same name and then okay file. Yeah, let's have some different name. And yeah, some other error. Let's do panic with other error. Yeah, I think that's it. Let's remove. Okay, let's start the Vim. Remove file txt and back to main RC file, and now let's do cargo run. And you see the file created again. Okay, let's continue. The type of the value that file open return inside the error variant is IO error, which is a struct provided by the standard library. So this error is a struct from the standard library, which is a method kind which return error kind, and the error kind has this is a num which has these items: not found, permission denied, connection refused, etc. All right. error, which is a struct provided by the standard library. This struct has a method kind that we can call to get an IO error kind value. The enum IO error kind is provided by the standard library and has variants representing the different kind of error that might result from IO operation. The variant we want to use is error kind not found, which indicate that file we're trying to open doesn't exist yet. So we match on greeting file result, but we also have an inner match on error kind. The condition we want to check in the inner match is whether the value returned by error kind is the not found variant of the error kind enum. If it is, we try to create the file with file create. However, because file create could also fail, we need a second arm in the inner match expression. When the file can be created, a different error message is printed. The second arm of the outer match stay the same, so the program panic on any error beside the missing file error. Alternative to using match with result. This is some note here. That's a lot of match, yeah, definitely. The match expression is very useful, but also very much a primitive. In the chapter 13, you'll learn about closure, which are used with many of the methods defined on result. This method can be more concise than using match when handling result values in your code. Yeah, it sounds good that there is some solution for, because you see it's 3 times match look like overwhelming a bit. For example, here is another way to write the same logic as shown in listing 9.5, this time using the closure and the unwrap or else method. Okay, I think we already did unwrap in the last stream, but yeah, not sure what we did with it. Anyways, so the listing is following. We do file open, and then immediately we do unwrap or else. So I guess if result is okay, we get in greeting file. In case not, the or else branch where the closure is happened, and this closure is like anonymous function. If you, for example, familiar with JavaScript, I believe you know what's going on here. So this is function with receive error, and then we check if kind is not found. We create a file and do again unwrap or else. It's actually a bit less of code, I guess, but yeah, I think it's look much simpler, but I guess it's a bit simpler. Yeah. Also, this code has the same behavior as listing 9.5. It doesn't contain any match expression and is cleaner to read. Yeah. Come back to this example after you read chapter 13 and look up the unwrap or else method in this standard library documentation. Many more of these methods can clean up huge nested match expression when you're dealing with errors. Okay, so let's continue, and next is shortcuts for panic on error, unwrap, and expect. Okay, using match works well enough, but it can be a bit verbose and doesn't always communicate intent well. The result type has many helper methods defined on it to do various more specific tasks. Yeah, I guess Rust result. So this is a num. Methods overview. Adapter and extract contained values. I think this is the section where I will look now. So there is unwrap, unwrap or default, unwrap or else. The panicking methods expect and unwrap require key to implement the debug trait. Okay, some unfamiliar stuff, but let's continue. The result type has many helper. Okay, the unwrap method is shortcut method implemented just like the match expression we wrote in listing 9.4. If the result value is the OK, if the OK variant, unwrap will return the value inside the OK. If the result is the error variant, unwrap will call the panic macro for us. Here is an example of unwrap in action. So let's quickly comment this. And let's do just unwrap, and you see its file. Okay, there is again something wrong happened here. Let me quickly restart and remove text file. And if I do cargo run, it will panic, right? Result unwrap. No such file or directory. Yeah, this is our error when file not exist or kind of not found. If we run this code without hello.txt file, we'll see an error message from the panic. Call the unwrap method makes. Yeah, we just did it. Similarly, the expect method let us also choose the panic error message using expect instead of unwrap, and providing good error messages can convey your intent and make tracking down the source of panic easier. The syntax of expect looks like this. And format did it this way, but I'm getting the errors. No method name expect. Is it just a phantom error? Let's do LSP restart. And there is no errors. No, it's again here. So clear, cargo run. So this is maybe unwrapped, shouldn't be here. Oh yeah, so this is expect is going instead of unwrap. That's why you see the error. So cargo run hello.txt. We actually have text.txt, so let's quickly replace it, and you see we get this error. Text.txt should be included in this project. Exactly the error we have. We use the expect in the same way as unwrap to return the file handle or call the panic macro. The error message used by expect in its call to panic will be the parameter that we pass to expect rather than the default panic message that unwrap uses. Here's what it looks like. Main panic at hello.txt should be included in this project. In production quality code, most rustition choose expect rather than unwrap and give more context about why the operation is expected to always succeed. That way, if your assumptions are ever proven wrong, you have more information to use in debugging. So yeah, definitely you would like to provide more context. Something goes wrong, then just a default panic. I think this is what usually happens. So propagating errors, our next step here. When a function's implementation calls something that might fail, instead of handling the error within the function itself, you can return the error to the calling code so that it can decide what to do. This is known as propagating the error and gives the more control to the calling code, where there might be more information or logic that dictates how the error should be handled than what you have available in the context of your code. Yeah, this is for sure something useful. You want to invoke the function and deal with the result, or whether it's error or it's success. you would like to decide outside of the function what to do with it in many cases. For example, listing 96 shows a function that reads a username from a file. If the file doesn't exist or can be read, this function will return those errors to the code that called the function. Okay. So let's see. Maybe let's just copy the function. I see some errors here because, okay, use std. Can I actually try to, yeah, I can use code actions here and import what I need, and here read to string on type file. Method not found in file. Is it fs file? Yeah. Will it help if I do it like this? So the IO self read. So if I, so this is from read to string. Okay. So not really obvious. And can be automatically resolved, I guess. Let's try again. We add it like this, and then can we, oh no, we actually can solve it. So let's take a look at the function itself. So file open as usually, you already know, have the result type here. Then we have match to get file or return an error. Oh, if we return this, so if we return either OK on error, it will be result return type. So we comment out this and just call it like this and run the program. It's worked just fine, and maybe what we can do expect hello txt from fn read username from file and in this case we will have string. So this is interesting because this is return value here, and this is return from the function itself, I guess. So if we replace it with this one, it will not work. Yeah. So it constantly breaks my in Vim3, but it's not a big deal. Let's create hello txt and username will be dmodel. Let's try to print username cargo run. Cool, it's working. Username. Okay, we created mutable string, then we mutated inside the read to string method, and that's why we do not care about what inside this. Okay, and we resolve okay with username string. All right, so this function can be written in much shorter way, but we are going to start by doing a lot of it manually in the order to explore error handling. At the end, we'll show the shorter way. Let's look at the return type of the function first. Return function first. So it's result, which leads to OK with value string, or error with IO error. This means the function is returning a value of the type result where generic parameter t has been filled in with the concrete type string, and generic type e has been filled in with the concrete type IO error. In this function succeed without any problems. The code that calls this function will receive an OK value that holds a string. The username that this function read from the file. If this function encounters any problem, the calling code will receive an error value that holds an instance of IO error that contains more information about what the problem was. We choose IO error as the return type of this function because that happens to be the type of the error value returned from both of the operations we are calling in this function body that might fail: the file open function and the read to string method. So both read to string and file open produce this IO error, so the same type. All right. Yeah, let me have a sip of water. The body of function starts by calling the file open function, and then we handle the result value with a match similar to the match in listing 9.4. If file open succeed, the file handle in the pattern variable file becomes the value in the mutable variable username file, and the function continues. In the error case, instead of calling panic, we use the return keyword to return early out of the function entirely and pass the error value from file open now in the pattern variable e back to the calling code as functions error value. So yeah, I miss this concept where we have, like, I'm not completely sure, but if we do just have something to the end of the block and it's returned to the upper scope, but if we have a return, we return from completely from the function. Maybe we read about it somewhere in the book, but I definitely miss it. So if we have a file handle in the username file, the function then creates a new string and variable username and call the read to string method on the file handle in the username file to read the content of the file into username. Yeah, we already take a look into it. In case we had handle of the file, we create the mutable string and put it inside read of string method of the file handle, and inside that function it filled with data read from the file. The read to string method also return a result because it might fail even though file open succeeded. So we need another match to handle that result. If the read to string succeed, then our function has succeeded and we return the username from the file that now in username wrapped in an OK. If read to string fails, we return the error value in the same way that we return the error value in the match. That handled the return value of file open. So yeah, a bit overwhelming, but anyway, so read of string may fail, so it return result, where in case of OK, we wrap it with OK and return the string username string inside the OK. In case of fail, we return basically we do can we just oh no, I thought we can just remove, but if it what it return result usize, so it's the size of bytes we read. So bytes size, and we can no. So um, 9 bytes red. Okay. So read to string return result, and we want to return result, but we recreate this result because the error will be the same, but we need to return username, and the to string return bytes of size, which not what we want. That's why we can just return result of read to string function. All right. So the code that called this code will return handle getting either an OK value that contains a username or an error value that contains an IO error. It's up to calling code to decide what to do with those values. If the calling code gets an error value, it could call panic and crash the program. Use a default username or look up the username from somewhere other than a file. For example, we don't have enough information on what the calling code is actually trying to do, so we propagate all the success or error information upward for it to handle appropriately. Maybe we can replace the expect with default, like unwrap or return the container to Kavana or computes it from a closure. So can we just put here default user name, and if we rename the hello the txt file, it's actually point to the error. Not implemented for str required. So example usage count. So return the container Kavela or computes it from a closure. Oh, we need to put a closure here. So haven't learned the closure yet, but we already saw them. And we want to return to string. And let's try to run it. So cargo run, default username, yeah. Can we make it a bit nicer maybe? But yeah, formatter, change it like this. Okay. Well, this pattern of propagation error is common in Rust, that the Rust provide the question mark operator to make this easier. So yeah, to the point where what this was about, it's about propagating error where we don't decide what to do with user read inside the function. We just trying to get it and then return the result instead of like exact value, which will be either the successful value or the appropriate error. A shortcut for propagating error, the question mark operator. A listing 97 shows an implementation of read username from file that has the same functionality as a listing 96, but this implementation uses the question mark operator. So okay, let's quickly let's actually comment it out. So the username is file, so the used in question mark to decide whether the operator should produce a value or propagate a value back to the caller. So I guess if okay, we have username file. If it's error, it will return from the function propagate to the caller. And same here. If the error, it will be returned to the caller, and if not, we will continue, and in this case we will have username and we will return it from the function wrapped with OK. So the result will be OK string. Yeah, much nicer, I must to say. And then this example, way cleaner. Yeah, when you just learning Rust, it just not scaring, but you feel like how it can be most loved language from the survey. But yeah, as it stands, the learning curve is hard. So I guess it's just the effect of learning, but feeling of using it might be way better. So really exciting when I'm reached to this point. So let's continue. The question mark placed after the result value is defined to work in almost the same way as the match expression. We define it to handle the result value in listing 9.6. If the value of the result is an OK, the value inside the OK will get returned from the expression and the program will continue. If the value is an error, the error will be returned from the whole function as if we had used the return keyword, so the error value gets propagated to the calling code. Yeah, we already get it. There is a difference between what the match expression there's a difference between what the match expression from listing 9.6 does and what the question mark operator does. Error value that have the question mark operator called on them go through the from function defined in the from trait in the standard library, which is used to convert values from one type into another. Okay. When the question mark operator called the from function, the error type received is converted into the error type defined in the return type of the current function. Oh, really? This is useful when a function returns one error type to represent all the ways a function might fail, even if parts might fail to many different reasons. Okay. I guess there will be some cases where it can be done, but I think we will find out it. For example, we could change the read username from file function in listing 9.7 to return a custom error type named our error that we define. If we also define implementation from for our error to construct an instance of our error from IO error, then the question mark operator call in the body of read username from file will call from and convert the error types without needing to add any more code to the function. In the context of listing 9.7, the question mark operator at the end of the file open call will return the value inside an OK to the variable username file. If an error occurs in the question mark operator will return early out of the whole function and give any error value to the calling code. The same thing applies to the question mark at the end of the read to string call. So yeah, maybe let's finish read and jump to the snippet. The question mark operator eliminates a lot of boilerplate and makes the function implementation simpler. We could even shorten this code further by changing method call immediately after the question mark as shown in the listing 9.8. So yeah, I want to back to this paragraph again. We could change the user read from file function, return a custom error type named our error. This is not correspond to this snippet. I thought it would be there, so it's not. So our error that we define, if we also define implementation from for our error, I think it is interesting, and we actually can try to do this. So the error is I think we can do very simple example. We can do struct our error which is even empty one, and our error implement from error is it correct syntax? Should be no. Let's quickly ask ChatGPT. So means something like this. Our error in Rust error that we define please also define implementation for our error. Okay, so implements for our error, right? And fn and now x no, not expect, maybe unwrap and default ponic. So if we do Carduran now, so we also need display. This is ChatGPT suggests us to have something like this. And let's quickly do super simple version. It expects URL. Right, to write formatted data into the buffer. Test volume. So import std what it expects. Write f. So this is test error. Derive debug. Okay, still cannot do it. We need derive debug as well. Okay, we got the value from hello.txt, but we all actually want to get our error, and panic with it. And so panic call to result unwrap on error value our error. It's not provide any additional info. Anyway, we're already messing up with Rust. Though it's not really useful, but at least trying to understand this concept was explained here. So question mark operator do call this from function. This from function to create our error from the std error and IO error. From this type we create in our error and automatically return it. If we don't have implement this method, it will not work. Okay, this is what going on under the hood when we do just IO error. And if we run it, yeah, you see it's panicked, but it provides more information from the IO error. Even it have IO error by default, it still do call from, I guess. At least I get it from this piece of text in the book. Okay, let's keep going. So remove the creation of the new okay, this is, we haven't played with this. Oh, this is nice. So let's comment this part, and so now we apply. I actually love the question mark in the TypeScript and the JavaScript. It allow me to not write like how to say it, like very big if this piece exists, if this piece exists, and etc. Just allow me to write compact and more safe code. And here we see the similar situation from this version, which is quite big. the result in this very compact way. Sorry, in this very compact way with just 3 lines. Actually, we can do it like this, and it will be a very small function. With empty lines is definitely more readable, but yeah. So we move the creation of the new string in username to the beginning of the function. That part hasn't changed. Instead of creating a variable username file, we've changed the call to read to string directly onto the result of open question mark operator. We still have question mark operator at the end of the read string call, and we still return OK value containing the username when both file open and read to string succeed rather than return an error. The functionality is again the same as in listing 9.6 and listing 9.7. This is just a different, more ergonomic way to write it. Cool. Listing 9.9 shows a way to make this even shorter using fs read to string. Okay, this is just directly read to string from the file name. Yeah, just let's run this version. Sorry, cargo run. It works. Comment it out and use this short version. I guess we need import. Yeah, we just did the import of fs self, I guess. Sorry, fs self. Yeah, now it's supposed to work just same way. Yeah, you see we have this username Dinadel, read it from hello.txt file in the root of our project. Reading a file into a string is a fairly common operation, so the standard library provides the convenient fs read to string function that opens the file, creates a new string, reads the content of the file, put the content into the string, and return it. Of course, using fs read to string doesn't give us the opportunity to explain all the error handling, so we did it the longer way. Okay, where the question mark operator can be used. The question mark operator can only be used in function whose return type is compatible with the value the question mark operator is used on. This is because the question mark operator is defined to perform an early return of a function of a value out of the function in the same manner as the match expression we defined it in the listing 9.6. In listing 9.6, the match was using a result value, and the early return arm returned the error value. The return type of the function has to be result, so that is compatible with return. Listing 9.10, let's look at the error we'll get if we use question mark operator in a main function with a return type incompatible with the type of the value we use. Yeah, just for sure. And yeah, let's run it. And the question mark operator can only be used in a function that return result or option or another type of implementation. And main is unit type. Yep. Is it? It's not shown here what it returned, but since we don't return anything, it return unit type. If I do like this, no problem. If I do something else, you see expected unit type. Okay. This code opens a file which might have failed. The question mark operator follows the result value returned by file open, but this main function has the return type of unit type, not result. When we compile this code, we get the following error message. Yeah, we already checked it, so let's continue. This error point, sorry, my mouse is broken. Let me mute myself for a second. So yeah, I have a cat, so sometimes my mouse not working. I need to clean up it a bit. This error point out that we are only allowed to use question mark operator in the functions that return result option or another type that implements from residual. To fix this error, you have two choices. One choice is to change the return type of your function to be compatible with the value you're using question mark operator on, as long as you have the restriction preventing that. The other technique is to use a match or one of the result methods to handle the result in whatever way is appropriate. The error message also mentioned that question mark can be used with option t value as well. As with using question mark on the result, you can only use question mark and an option in function that return an option. The behavior of the question mark operator when called on option t is similar to its behavior when called on a result t if value is known. Is known will be returned early from the function at that point. If the value is sum, the value inside the sum is the resulting value of the expression and the function continues. Listing 911 has an example of function that finds last character of the first line in the given text. So basically, let's try out. Discuss it shortly. So let's char hello sums. So let's see what is the type option char. Okay, so we have text slice in the text. Then we call the lines which return lines. Next, it's something advanced the iterator to return the next value. So we take first line, then yeah, if the line exists, we take chars, and from chars we take last. And last return an option. Consume the iterator returning the last element. This means we evaluate the iterator until it returns. While doing so, it keeps track. So let's print out the result. And let's play a bit with import after. So last char is G for something, and it takes lines. So I just wonder if I put new line character here, will it change the, yeah, you see it will be O in this case. Actually it's some O. Can we unwrap it as well? Or even expect. Yeah. Empty line. First line is empty line. So current run, and we have last character of the first line. But what if we have new line character and start, and there should be empty line. It panics with our text from expect. First line is empty line, you see. Okay. So I think what happened in this case, the next is none, and it's oh, it's not none, it's empty line, and then last is let's actually print out what is next. So clear cargo run. Yeah, next is empty line, so the last will be empty. But what, in which case next will be none? If we put empty line, is it possible? So yeah, in this case, if we put empty line, it returns none for the next. Okay. So this function return option char because it's possible that there is a character there, but it's also possible that there isn't. The code takes the text string slice argument and call the lines method on it, which return the iterator over the lines in the string. Because this function wants to examine the first line, it calls next on the iterator to get the first value from the iterator. If the text is the empty string, this call to next will return none. Yeah, we found out it ourselves that if the text is empty string, this call next will return the none, in which case we use question mark operator to stop and return none from the last char of first line. If text is not the empty string, next will return a some value containing a string slice of the first line in the text. Okay. The question mark extract the string slice, and we can call chars on that string slice to get an iterator of its characters. We are interested in the last character in this first line, so we call last to return the last item in the iterator. This is an option because it's possible that the first line is the empty string. For example, if text starts with the blank line, but yeah, we test this case exactly, but has characters on other lines as in this line. However, if there is a last character on the first line, it will be returned in some variant. The question mark operator in the middle gives us a concise way to express this logic, allowing us to implement the function in one line. If we couldn't use question mark operator on option, we would have to implement this logic using more methods call or a match expression. Note that you can use the question mark operator on the result in a function that returns result, and you can use it for the option in a function that returns an option, but you can't mix and match. Yeah, kind of obvious for me, maybe for some new developer. Not for everyone, maybe from first time, but yeah, different times we can return either option, either result. The question mark operator won't automatically convert result to option or vice versa. In those cases, you can use methods like OK method on result or the awk or method on option to do the conversion explicitly. Okay. So for all the main functions, we use return unit type. The main function is special because it's the entry and exit point of executable program, and there are restrictions on what its return type can be for the programs to behave as expected. Luckily, main can also return a result of OK unit or error. Listing 9.12 has the code from 9.10, but we have changed the return type of main to be result and added a result value OK to the end. This code will now compile. Okay. So yeah, let's just do this quickly. So we have a result like this, and so I think we need to import it. It's IO error, I guess. Yeah, so sorry, just missed the case, but yeah, no, still get an error. Just analyzer syntax error, expected a block. Oh, what I've done. Yesterday error. Okay, it's not IO. It it is error. So further run, and we are good. So the box, I don't know what it is. Din error. Type is trait object, which we'll talk about in the using trait object and alone. Where it is. Okay, chapter 17. Yeah. For now, you can read the box din error to mean any kind of error using question mark on the result value in a main function with the error type is allowed because it allowed any error value to be returned early. Even so, the body of this main function will only ever return error of type stdio error by specifying box din error. This signature will continue to be correct even if more code that return other errors is added to the body of the main. So when a main function returns a result, the executable will exit with a value of 0 if main returns OK. Okay, executable return is 0 if it's returned OK. And will exit with a non-zero value if main returns an error value. Executables are written in C return integer when they exit program that exit successfully return the integer 0, and program that error returns some integer other than 0. Rust also return integers from executables to be compatible with this convention. Okay, we in convention with C in this place. The main function may return any type that implements okay, some termination, so some trait, okay, which contain a function report that return an exit code. Consult the standard library documentation for more information on implementing the termination trait for your own types. Now that we discussed the details of calling panic or return results, let's return to the topic of how to decide which is appropriate to use in which cases. Alright, this was a long section, 2.5 hours I'm streaming now, and yeah, it's already quite hard to concentrate to read the book. Yeah, usually I do smaller streams for this. So we finish right now. Thank you for watching. See you on the next streams. Bye guys.